Okay, sir. Sir, I think you haven't shown your slides now, sir, yet,
Yeah,
because
I will
slide.
show. Because yeah, one of my PhD scholar is joining because my SPSS is also not working.
Okay.
It is some doing some problem. So I asked my scholar to join, and she will open, and I will guide her, and she will give the demo of the same, how to carry out the analysis of the complete block designs. So completely randomized design, randomized block design, and lattice square design. That is analysis of various one-way classification and two-way classifications. Just now within 2 minutes. Give the extension cable also. Uh, Actually, today's topic is the factorial experiments, and I said that I will give some the demo on the implementation, the practical implementation by using the software of the completely randomized design and randomized block designs and lattice square design, or and also the analysis of variance, one-way classification, two-way classification, and two-way classification with interaction also. So these are all that you can implement by using the various softwares, even including that you can use SPSS software, R software, or Python, and design expert is specifically only for the design of experiments. And there are some other software, SysStat, Softcraft, and so on. So R is generally in the R and Python, which are program oriented, and most of them they are not familiar with the programming. So therefore, it is better to use either SPSS, which is totally is a menu driven and which is very easy to use it. And also the design expert, but it is a both are design expert and mm, SPSS. So these are the softwares that you have to purchase only. So otherwise, you can go for the trial version. Yesterday, that from the start is you can download the design expert, which of the uh, whatever the educational enterprise version is only available for the design expert, which is a trial version. So which is valid for 1 month, and you can use for the basic designs like CRD, RBD, LSD, and some incomplete block designs, and response surfaces, mixture experiments, and Taguchi designs. So these designs that are available using the design expert. Even for the you can also use SysStat or Statistica or StatLab. So these are also uh, providing the statistical tools. Uh, is Anush is the call is joined? No. Okay. Uh, okay. Meanwhile, that I will start the another session.
Sir, does the link was shared with your student, sir, or should I send?
Hello. So when you are using the software, either Design Expert or Statistica or SysStat or uh, R programming or Python or by using the SPSS. So this is a completely randomized design, which that I want to evaluate the carry out the analysis. So This is the data. Now, how to enter this data and how to carry out the analysis, that I will explain with using the SPSS software. So here we are having totally the 4 treatments are there: A, B, C, D. Okay. So these that I'm indicating with 1, 2, 3, 4. And corresponding to A, how many observations are there? So that you have to consider. So these are A 10.2, 9.5, and the another 5.4. So these are the observations. So just generally, whenever you are using, mm, you know, suppose if you are using this one, this is a, treatment and response. Okay, and so treatment. So corresponding to treatment A, let's suppose. So treatment A, we are having how many observations are there? Suppose we are having 4 observations are there. You write first observation, second, third, and fourth. And what are the observations? So let's suppose 5.4, uh, 5.4, uh, 3.8, uh, some 5.1, and 6.3. 6 point. And similarly, the treatment B. So let's suppose we are having only uh, 3 observations, and those observations that you have to enter it here: 5.8, 7.1, 6.7. And let's suppose treatment C. Okay, and here uh, treatment C that is applied in 3 places: 1, 2, 3, 4. Let's suppose 5 places,
Sir,
and
good
you have to
morning, sir.
enter those.
Sorry for interruption, sir. Are you entering the data anywhere, sir?
Yeah, here I'm entering how to enter the data in SPSS.
But we can't see, sir, that.
Oh, okay. Hmm. Yeah,
Sir, it is Excel sheet what you are showing, sir?
yeah, Excel sheet that I'm showing it.
Okay, okay. We
Actually,
can
the
see.
software is not working now. One of my scholar will join now, and
Okay,
I requested her to join by using the SPSS.
okay, sir.
So on that I will explain it. Okay. So
Okay,
shortly
okay,
she will
sir.
join. So meanwhile,
Okay,
that
sir.
how to enter the data that I'm explaining now.
Okay, sir. Right. Thank you, sir.
So here, yeah. Uh, so generally we are having data view and data. So data variables and data view. There are two that are buttons that are there on the SPSS on the bottom, and on the data view and data variable. Data variable, under that how many are there that you have to write. So first you have to write a treatment. The next whatever the observation you write. Okay, and actual response that I'm writing. This is nothing but sorry, replication, and this is response. So data variable view, we have to create 3. One is treatment, the second one is replication, the third one is response. So under the treatment, then you go to the data view, and so you will get three columns like this. Then you have to enter the observations. So let's suppose there are three treatments are there, A, B, and C. So treatment A, that is entered, A, 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 A. So four observations are there. The A treatment is applied. B treatment is applied and at three places, and C treatment is applied at five places. So you write like this. Then on the replication, so you have to mention. So A treatment is at four places, and B treatment is applied three places. So 1, 2, 3. So four replication, three replications, five replications. Under the response column, actual observation that you have to enter. Like this. Okay. Whether she's joined? Hello?
Yes. What is the name, sir?
CH
Name of your
Anusha.
student?
Anusha.
I don't know. No, sir, she hasn't joined. I didn't get any request yet.
You didn't get any request?
Yes,
Okay.
sir, yes.
Okay. That I will show this part in the end once that she joined, and I will start the another topic. Okay. This is
Okay.
actually how to enter the data. Then once that data is entered, then you have to go to the on the top analyze button. So under the analyze button, you have to univariate case, univariate. So under the univariate one-way classification, so that you have to select it. So automatically the data will be selected automatically, and you will get output. So very simple to use.
Sir, you
So
want me to share the design expert? I have the design expert with me.
yeah, you can share.
Okay, can I request the
But
person to give me the
I
sharing
know I
option?
already given the
Yes,
trial version that I'm getting some problem with the trial version.
No, I'll give you
Yesterday
the
night
full
that
version.
I
I have the other version, sir. 12 version I have. I will share it with you.
yeah, but
okay,
online
ma'am.
it is not possible to share.
Should I make you presenter, ma'am?
No.
Yeah, you give me as a co-host. I will share the screen so that sir can use it, or how to do. Can you tell me like that?
Dr. Sampati Sunita
Yes.
is your name, ma'am? Yes.
Yeah.
No, I will give the demo in the end part, madam.
Okay.
First, I will go for the another part. Then we'll see that one. Okay.
Okay. Okay, sir. Right. As you wish, sir. Okay, sir. Continue, sir. Right. Thank you.
Uh, because of those three, it may take maximum of 5 to 10 minutes only. So whatever the completely randomized design and randomized block design and Latin square design. So maximum of 5 minutes only. So we can also explain. I can demo on the last 5 minutes. Now, the next major topic is the factorial experiments. Hello, getting disturbance?
Yes, sir.
Okay, right.
Sir, Anusha, I think, has joined, sir.
Joined.
Yes, sir.
Okay.
I muted her because of the disturbance. Now I'll unmute.
Hmm. You give the sharing to her. She will
Okay.
open the SPSS software.
I have Anusha ma'am, I have given you the presenter. Kindly unmute yourself and show the presentation.
Hello, Anusha.
She has muted herself. She has muted, sir. Tell her to kindly unmute herself.
Okay.
Anusha ma'am, kindly unmute yourself and.
Yes, sir. Yes, sir. Am I audible?
Yeah, audible. Anusha, you share the screen.
Okay, sir.
You go to the present presentation or open share tray.
Yes.
In the middle arrow mark is there.
Yes, yes.
And open the Spaces software and select that one. Share the screen. Is it working now?
Sir, is it visible?
No, you are not shared, I think.
Share.
ఇందాక షేర్ చేసింది మళ్ళీ
Just a minute. Now, sir, is it visible?
No, yeah, it is visible.
Yes.
Okay. Now, here you go to the variable view.
Yes, sir.
Is it visible to all of you?
Yes, sir.
Now select the variable view. So in the variable view, so you are getting the just like it is a Excel sheet model only, simple. Now you write it here, treatment. Okay, treat. Enter, just enter. Okay. So here you are getting the value decimals that you put as 0. Label as treatment. Okay, that's treat. Next, replication second. Here, go to the name. Second variable that you create, replication. So here, here also that you give the decimal value as 0. And you write a replication. And the third one, response or observations. You write observations that you write. Observe. So it will take only the 8 characters. So you take that one, and here you write an observations or response, anyone. So once that you are for the completely randomized design, you are getting treatment, replication, and observations. Okay. Then go to the data view. So in the data view, you are getting the treatment, replication, and observations. Now treatment A that you enter in 4 columns. Enter A.
It is not.
Write A, and you write 1, 2, 3 because in digital that is given 1. Okay. 1 only. So A is indicating 1. So treatment 1, again 1. Okay. So first treatment with 4 replication. In the second replication, you write 1, 2, 3, 4. Now here you write second treatment 2. Instead of B, that you write 2.
Here, sir, treatment.
Yeah. 2, and next 2. So 3 times that you have written. 4 times. Okay, another 1 also that you write.
Yes, sir.
5 times.
So 1 is 5 times, sir.
No. This is 2 is 5 times.
Okay, sir.
Uh, you write 1, 2, 3. 4, 5. And the third treatment 3. 3 times that you write. And you write 1, 2, 3. Now you enter some random observations at here. Some 5.2. Next 5.7. 5.8. 6.2. 6.8. 6.8. 6.8.
Again 6.8.
Yeah. And okay, you enter some observations randomly. Okay. Okay. Now, so here treatments, replications, and observations are there. Now you carry out the analysis. Go to analyze and univariate. So in the your univariate, yeah. So in the treatment, replications, and observations. Okay. And also you cancel this one. Cancel and go to analyze. Go to analyze and compare means. Compare means.
Yes.
Okay. In the compare means, the last one way ANOVA, that you select it. Okay. And whatever the dependent list and the factor is treatment, not replication, treatment. Okay. And the observation that you send to the dependent list. Huh?
Yes.
Okay, and select the post hoc and select LSD, least significant digit, and Tukey's t-test, Tukey, and DMR, Duncan's DMR stands for Duncan multiple range test, and Shafi is indicating Shafi's t-test. So here I'm selecting 4, but no need to select 4. Any one is enough. So either Duncan or Shafi or LSD or Tukey. Any one is enough. Okay. And we are testing the significance level is only the 5%. Now continue. Now said OK. Got the output?
Yes.
Output screen that you have to share. What's in the output?
Yeah, వచ్చింది sir. Again, I have to share the screen, sir.
Yeah, it is not visible to all. You select that one from the presentation, open tray share, select it. Select. Yeah. So you are getting the output is like this. Okay. So you scroll it and show this is analysis of variance one-way classification, ANOVA table, and between the groups and within groups. Within group is nothing but error, and between groups means between the treatments. And whatever the values, the sum of squares values and total value. And degrees of freedom, 2 degrees of freedom because I had taken 3 treatments only, A, B, C, or 1, 2, 3. So 3 minus 1. And totally, how many observations that you have taken? On first one, 4, second one, 5, and on third treatment, how many?
12. 12 observations total.
So 12 observations minus 1. And 12 minus 11 minus 2, that is 9, is the degrees of freedom. Okay. And the mean square value, sum of squares value by its degrees of freedom, 15.26 by 2, that you will get, this is the value, 7.631. Similarly, within group, that is nothing but error sum of squares. So 7.136 by 9, you will get the value is 0.793. Then compute the mean square between groups by within group. So error value is less and between groups is more, and this is the value. And whatever the significance value that you are writing it. Okay. So this is the p value that which is whether the hypothesis is accepted or that is indicating it here. And next, this is the multiple comparison test. So there are different tests that I have selected. So either Tukey's t-test or Safi's t-test or LSD or Duncan's multiple range test. Now we are having 3 treatments, treatment 1, 2, 3. Treatment 1 is compared with 2 and also 3. 2 is compared with 1 and 3. And third treatment is compared with 1 and also 2. And the mean differences, whatever the average value of the treatment 1 and treatment 2, the difference that is calculating by using the Tukey's t-test statistic formula. And whatever the variation that is also presented and its significance value that is tabulated at here. and here whatever the star, so whether it is accepted or rejected. Anusha? So here the star is indicating the value. Just to scroll down, and the star is that is mentioned at here. The mean difference is significant at 5% level, because in the level of significance that I set it 0.05. So the t-test that is evaluated, and whatever wherever the star is there. So that means 1 and 3 there is a significance difference. And even if you are using the according to the two case, even Shafi is also that you can check it 1 and 3, the value is 2.1, which is a significant value. And the another one in LSD also, so the same value it is showing it nearly, so which is a significant value. And also check it once in the DMR Duncan's. Duncan's is not done,
No, sir.
not selected. Yeah, it is there. In the bottom is there. So 3, 1 and 2. So 3, 3 and 2, 1, 4 and 2, 5. So here the number of observation that is indicated at here, and two cases also how many observations, and their alpha level values, those are tabulated. So actually, if the hypothesis is rejected, generally we are going for this Duncan's multiple range test. Okay, just to go up and show the ANOVA table. Anusha?
Sir.
Yeah, this is. So any doubt about this one? Okay.
No, sir.
So how to enter the data in SPSS? Just you have to go to the data variable and select three variables that you have to create. One is treatment. The second one is the replication, because each treatment how many times that you are applied. So that is replication. And the third one is actual responses. And those that you are entered, and then we are going for the analyze. Okay. So in the analyze button, we are selecting the compare means. In the compare means, the next you are selecting analysis, one-way analysis. So directly you are getting this screen, and we are getting some options are also there. Whatever the observations are dependent, and treatments are sending to uh, the factor, and you are setting the value of alpha, and also you are selecting the uh, multiple comparisons post hoc tests that are selected. So these are ones that you are selected one way ANOVA, those that you are showing it. Okay. Again, please repeat the same process and show it, Anusha. Screen, oh, yeah. You share the screen of the table, and again the same. If you are having any of the doubts, that you can ask, unmute and ask now. Any doubt about this one? So this is the once that you are opened the SPSS software, you are getting this screen. Okay. And just you go to the data variable view. First you have to go to the variable view and enter treatment, replication and classes. Okay. And so then you have to go for the uh, treatments are nominal, and replications is also nominal, because these are not actual observations. So I had already told what is the measurement of scale, and only the observations are on the scale or on the interval scale specifically. Okay. So the treatment is A, B, C that you can use in case if you are setting the value instead of the values as none that I have placed it. Instead of that, you can also use the labeling value. Okay. So then go to the variable view. So enter the what are the treatment that you are having, each treatment, how many times that is repeated, and what are the corresponding observations. And second treatment, how many replications are there and what are the corresponding observations. And third treatment, 3 times repeated, and the observations that you are entering it. So once that you are entering, then go to analyze, then select compare means, then go to one-way ANOVA. So once that you are selecting, you are getting another dialog box of this one, and in this one that you send whatever the you set reset it. Yeah. Uh, treatment that you send it to factor, and observation that you send it to dependent list, and select post hoc test. And I'm selecting now only one of the tests, that is the LSD. Okay. And you set the value of P7 is 0.05. Even the equal variance also that you can maybe assume it. There is no problem at all here. Equal thymine or any one that you can select it. Okay. Continue. And the next you select the OK. You are getting the output value. Okay. So this is the implementation of the completely randomized design or analysis of variance one-way classification. Now I will give the two-way classification. Okay. So in the two-way classification, just to select the another one. This you can, Anusha, you enter some data of two-way classification. One treatment one exactly some 5 times, and 2 5 times, and 3 also 5 times. So one-way ANOVA, the treatments are replicated unequal number of times, maybe equal also. Okay. But whereas in the two-way classification, the first treatment is applied at 5 replications. The second also must be 5, and third also must be 5. So must be equal number of times. Now enter the observations corresponding. Yeah. Now go to, so this is the how we are entering the data. The same first here also in the whenever you are going for RBD, first you have to go to variable view and treatments, replications and observations. Same that you are entering it. Okay. And then go to the data view and you have to enter the observations like this. Only the difference between one-way and two-way, one-way replications may be unequal for the treatments, but whereas in two-way it must be equal. That is only the major difference. And here there is another part also we are calling, instead of the replication, there is also called the blocking. So in the variable view that you call as block. Most of them they are not calling as replication, they are calling as block. So we can test the hypothesis in two ways. One is the row wise, that is treatment wise, and other one is column wise, that is called block wise. Two hypotheses that you can test it here. And now the observations. Now go to analyze and go to not compare means go to univariate. Yeah. So you have selected. Have you observed it? Oh, go back. Cancel it and go back. Go to analyze. Then select general linear model GLM. In the general linear model that you have to select univariate. There are multivariate analysis of variance and also repeated measures. So 3 are there. And also the variance component analysis. So this is also whenever the effects are random, in those cases that you are going for the variance component analysis. So all are under the part of general linear model. So there is a general linear models. Another is also there. The uh, general model, linear model, 3 type actually it is. Now go to univariate. Now whatever the fixed effects are, the treatment effects are fixed, and whatever the blocks are also fixed. Okay. Now suppose if it is a random, any one, then you have to send it to here. Suppose treatment effects are random, then you are sending, then it is not analysis of variance, it is comes under the part of variance component analysis. Okay. Now observation that you send it to the dependent list. Okay. Then you can go for the post hoc test, and post hoc test that I'm setting for treatments. Yeah. So generally we are going for mostly the treatments only, not for the blocks. Even if you want the blocks also, you can set it. Okay. But here I'm setting only for treatments. Then you go for LSD test and Duncan's, Tukey's, and Sheffy. Okay. Then continue. Then okay. So whatever the output that you share the screen. Yeah. So here the treatment, there are 3 treatments are there. Each treatment is 5 observations only and replication that you got. But actually, because in the labeling that had given replication. Suppose in the labeling, if you are writing as block, then here you will get block only. Now there are 5 blocks are there. Each block is containing 3 observations. Okay. Then go to down little bit. ఇంకా కొంచెం పైకి పోనీయమ్మా. కింద కింద కింద.
Only these two.
Yeah, test for between subject experts that you show it. So this is the analysis of variance total table, the corrected model. So model fitting, this is actually, and intercept of the model, that is also you are getting, but these are not required. So we are mainly requiring the treatment, block, and error, and total. Okay. And the interaction effect, that is we have to delete actually. So no need to go for the interaction, but automatically it is selected. So you can hide that part. So then only you are getting, you check it once at here. Then whatever the interaction effect 28 will comes under the error. In case if you are deleting the interaction effect. So with interaction and without interaction, 2 are there. That what I told. So whenever you are selecting the with interaction, then you are getting like this. So combined effect of treatment and block. So that effect is also there. If you are not having that one, this comes under showing under the error part, because the error is showing the 0, because here are taken the observations are random observations. That's why you are getting 0. And actually, whenever you are taking the more replication, that you have to consider it. Otherwise, you are getting the degrees of freedom will be 0. So the degrees of freedom should not get zeros. If you are getting 0, then it is invalid. So what is the problem with this one? Is if you are you have to increase either the treatments or the replications. If you are increasing the replications, then automatically the error value having some degrees of freedom. That means observations must be repeated. If the less number of replications, the error degrees of freedom will be getting 0. So please remember that part. So more replication that you have to give it. So to avoid 0 at here, then only it will be accurate. Otherwise, there's some problem in the ANOVA table. Now, actually, whatever this 28 will comes at here, and 8 also will comes to here if you are ignoring that interaction effect. So treatment and block, there is no change. And you check it once, the degrees of freedom. The degrees of freedom for the treatment is 2 and block is 4. So 3 treatment that I had taken and 5 blocks that I had taken. And totally you are having how many observations? So 15 observations are there. So because 3 into 5, 15. Okay. And this is an uncorrected. So correction factor is not included in this one. Now, whatever the mean square values that are calculated, because error value will be 0, that's why it is not showing the significance at here. Suppose if the value is existing, then only it will shows. Okay, so just to go down and you increase the number of replications blocks, then you will get the value will be 0, that you show it in the later. Yeah, please increase the 7 observations or 8 observations. Increase the row. Yeah, just oh, okay, just here also 2 1, then the last 2 3 1. Yes, here observations is write as 6 and 7.
Yes.
6 and 7. Yeah, and 1 2 3 4 5. Yeah, no, 7 that you have to take, because 2 also 7 equal. These 2 that you change 3 2 2. Yes, now 3 7 times. Similarly 1 2 3 4 5 6 7 blocks. Yeah, next you observe, enter some observations randomly. Okay, now go to analyze. Univariate. Yeah, you reset it now. Uh, now send your treatment and blocks. Just one, you cancel it. Reset. Yeah, you go to the variable view, and instead of replication that you write as block. Yeah. Okay. Right. Now you go to analyze. Fixed effect, block also fixed effect. Okay. Observations that you send to dependent list, and post hoc test. Yeah. Okay, continue. Then you show the other part, the model that you select. You select model. In that one only. Gone?
Yes.
It is not visible too.
Yes, yes, yes.
Okay. Because there are different options, will show it, whether model and interaction and the other parts also. You are getting 7 observations and 3.
Is it okay, sir?
It is now okay. It is showing it now. Error is 0 that you are getting, because in that one I want to hide the interaction effect. Interaction effect and correction and intercept that I want to. I don't want these parts. Go to analyze.
So can I go to the
Yeah, go to the data. Yeah, go to the data. Univariate. Now you select whatever the model. Yeah. So this is a full factorial and custom. Okay. So and type 3, just you include intercept model that you don't select it. A tick mark this is right. Continue. So if you are including this one, then it will displace the whatever the value. Otherwise it won't. Next you select the go to the options. Option that you select.
yes, sir.
Okay. Display means, treatment mean, and block means. Okay. Interaction that you delete. Okay. Compare mean effects. Then descriptive statistics. Okay. Next, continue. And you show the plots. Yeah. Horizontal or treatments and blocks. Okay. Separate plots. Okay. Yeah. Continue. And go to contrast. Okay. None. So these are not selected. Okay. Continue. And what are the other values are there? model, contrast, and options. So yeah. So that's enough. Then work. But interaction effect that you should not get it in the options that you go. The third one that you have to delete actually. Display means there is one option is there for uh, not showing the okay. Go to you continue it and continue. Go to contrast. Univariate. Contrast none. Univariate. Okay. Yes. There is one option is there that you have to see. Actually, we are not getting the interaction also. We can nullify that part. Otherwise, you can. Okay. Okay. Continue. Continue. Okay. Now you show the screen. Output. Okay. Okay. These are dependent variable observations. Okay. The mean values of for the 7 that are given. First treatment and 7 blocks. Or second treatment, whatever the 7 blocks may be changing from order only. There is no difference. And standard deviation. So those are also will shows. Okay. First treatment, standard deviation, second treatment, third treatment, and so on. Okay. Next, continue, go down. Yeah. So here the model, treatment, block, and interaction effect and error. So we have to get the more number by increasing of 3 or something. Okay, no problem at all. So this is required. The R square value is 1 adjusted R square. So that is the model is fitted 100%. So that means the model is exactly fitted. So and the data is showing insignificant. There is no difference in the means, or there is no difference in the blocks. So that what it is showing it. So because the value is 0.44 and the error value is almost 0, therefore it is indicating insignificant. So because R square value, the coefficient of determination and adjusted R square. So those values are showing here 1. It is indicating that it is perfectly, the model is fitted. That's what it is showing it. Next, go down. Yeah, this is the treatment. Estimated the standard error values. Go down, because I have not selected the estimates. We have not selected confidence intervals. These are also all insignificant. That's why you are not getting the values at here. Next. Diagrams that you are not getting, no? Yeah.
No, sir.
Right. Okay, that's all. So these are all the various options are there for implementation of the either two-way classification or randomizer block design. Now go to the lattice square design, LSD. So you create, go to variable view. Now first you write row. Second you write as column. Third one that you write as treatment. Okay. And fourth one write as an observation. Enter. Just enter. Okay. And this is treatment that you decimal value is 0. Okay, and observe this is not observation. You write as treatment label treatment corresponding. Okay, that is row. Label as row, and second one as column. The third one as treatment. The next one that you as observation or responses. Responses. Okay. All right. Here values. You show the values column. No. In the variable view only. Values of the row that you selected. Yeah. You select the side. Here the labeling, and these are also that you can give it if you want. Otherwise, automatically none. Okay. You cancel it. Now go to the data view. Here also you go to the variable view, and here that you take as the treatment as also nominal measurement. Yeah, nominal, and this is as scale. Okay, right. Now you you take the 5 by 5 4 by 4 Latin square design. Only 4. 1 2 3 4 4 ones. Yeah.
I'm canceling it.
Delete. Yeah, మొత్తం select చేసుకొని delete చేసి. You delete all. Then you write a 4 by 4 lattice square design. Yeah. 1 2 3 4. Next again 1 2 3 4 continuous. No. Don't write like that. ఇక్కడ రాయండి. So ఏ రోలోనే మళ్ళీ again 1 2 3 4. Next again 1 2 3 4. Again 1 2 3 4. Okay. Yeah. Here 1 column is 1. 1. Next 1. 1. 1. Next 2. 4 twos. Next 3s. Yeah. Right. Good. Next treatments. You write as first row, first column, 1. Okay. And first row, second column. Here 2. You write first row, second column, 2. 2. First row, third column, 3. First row, fourth column, 4. Next, second row, first column, 2. Okay. Next, second row, second column, 3. Next, 4. Second row, third column. Next, 1. 1, 1, 1, 1. Yeah. Next, third row, first column, 3. 3. Next, third row, second column, 4. 1. Next, 2. Next, similarly, fourth row, first column, 4. Yeah. And 3, 2, 1. Okay. Is it 1, 2, 3? Now
Is
write
this-
the observations. You enter some observations randomly that you enter some values. Okay. Now, next you go to the you implement the analyze univariate. Okay, and even row, column, and treatment. Okay, row, column, and treatment. Fixed effects. Okay, treatment also. Okay, right. Responses dependent. Okay, and post hoc tests may not be required. You write only for treatment. Okay. One only that you select LSD. That's enough. Okay. Continue. And just you select OK button. So this is row, column, and treatments. So I will show the. I think all of you seen the lattice square design. Yeah. Okay. So there are 4 rows, 4 columns, and 4 treatments. And the design will be just like A, B, C, D, B, C, D, A, C, D, A, B, D, A, B, C. So this is the lattice square design. Each treatment is appearing only once either in row or column, such that such a design is generally said to be a lattice square design. So that is considered it here. Now, so this is a 4 rows, 4 columns, and 4 treatment. Go down. Yeah, continue. Scroll. Yeah, this is. So here, row, type 3 sum of squares, and column, and go to the down, because it is not showing the values at here. All are zeros. Similar values are there. No, no, no. That is entirely the two-way. So row, column, and treatment, and there are some interactions are there. Okay. So only these 3, the values also they are showing very little values. What are the actual values? Show it. Please show the
Yes.
table. Okay, 2.2, 3.3, 2.2, and 1.1. Okay. So very little values are there. So it is not showing it.
Can I
Okay.
take
No
in
problem.
hundreds?
Yeah, making hundreds, then large values that you put it. And also you have to model that you have to hide it, and the interaction that you have to hide it. Customs model that you take, not full factorial.
Oh, yes.
Just you are entering the observations in the response column. Even for the 3-way or 4-way, with interaction or without interaction, there is no difference in the entering of the data. So we have to go for the variable view and data view, and we have to enter just like row, column, treatment, and so on. Suppose if it is a four-way model, row, column, treatment, and some other column, and then you have to go write the last column as a response. Okay. Then go to the analyze, general linear, univariate, a model that you nullify it, a model, include model intercept that you delete. Okay. The interaction that you select, interaction, yeah. Only main effects. Bus. Okay. Customs. Okay. Main effects type 3 and model. You select the full factorial. Full factorial. Okay. Okay. Include customs. Customs. So when you are selecting, you are not getting the continuous hided. Okay. Go to only full factorial. Continue. Continue. And contrast, any factors, row, column, and treatments. Contrast, change, none. Okay, continue. Then go for the options. Display means of treatments, only treatment that you show it. Only treatment. Okay. Descriptive statistics that you select it. Okay. And test for homogeneity also you can select. And test for estimates of not required, and residual plots, lack of fit, those are not required. Not required. So lack of fit of the model, if it is you are carrying out the regression analysis, in those cases that you are going to use, not at here. Continue. Then select OK. So interactions that you are getting, and actually there is one option is there. You are not going to get the interactions. So due to interaction that you are getting, the other values will be error value, degrees of freedom will be reduced it. So still the values are zeros. There's some problem is there in the data. Okay, mean values. Go down. Okay, that's enough. This is the actually I'm not getting the values accurate. This is only the ANOVA table, the above table. Just to show only the ANOVA table. Yeah, this part. Here this is the model and row sum of squares, column sum of squares, and treatment only. And the other three, those are not required. I think it may be type 3 that you have selected, maybe some type 4 or type 2. So due to that, we have to trial it because I'm not remembering. So that you can check it once in the later. Okay. Okay, right. So any more the doubts about the same using the SPSS? Yeah.
Sir, one small doubt, sir, actually. So I am using this particular statistical analysis when we do the in vivo studies, okay, in animals.
Okay.
So normally in the animals we use three groups.
Okay.
One is test group where we do our formulation.
Yeah, control.
The second one is the blank group.
Okay.
That is blank formulation without the drug. Third one is control group.
Yes.
Okay. In each group we take six animals.
Okay.
So we have three groups. So when I'm going to subject for the statistical analysis for ANOVA, I should use one-way analysis or which one I need to use, sir, for the three groups?
One way.
One way.
One way.
Okay.
because your six are replication, repeated observations.
Yes, yes, six are
So
replications.
so those are not separate blocks or some other treatment that you are not going to use.
Okay,
So
yes.
that's why you are going for one way only. So was
Okay.
there be any difference between control group to the test group or some other group? So
Yeah,
that's what you are going to test.
right.
So it is only one way analysis.
Okay, sir. Okay,
So in
sir.
the one way analysis, you write at here whatever the group numbers you write as 1, 2, 3 only.
Okay.
Okay,
Yeah.
and whatever the replications, one you that you write 6 times, and here write 1, 2, 6, and
Okay.
two that you write 6 times, and here
Okay.
also 1, 2, 3, 4, 5, 6, and
Okay.
three that you write 6 times, and
Okay.
1, 2, 3, 4, 5, 6, and
Oh,
whatever the observation that you enter it here, and
okay.
just go to the analyze button, and
Yeah.
then select the compare means, and
Uh,
select one way analysis of variance.
okay. Right, sir.
Okay.
Okay. Okay, sir. Now, this is one thing, sir. But if we, apart from the test,
Hmm.
blank and control, if I use a standard group, that means a standard marketed drug of the same drug.
Hmm.
So I will have four groups now.
Okay.
So here also we should go for one way because standard should be compared
One
with
way
the
only.
test one
Yes.
way only.
Yes. One way only. One way only.
Okay, okay. So when
If
I can
every pair
use,
separately, if you want to compare,
okay, sir.
then use automatically the post hoc tests are there.
Okay,
So
okay.
post hoc tests are nothing but every pair it is comparing it.
Every pair it is going to compare the post hoc
Yeah.
test. Yes, sir.
Yeah. So that what I had already shown to you.
Yes, yes,
Uh,
yes.
so every pair automatically it will be compared and you will show.
Okay. So when we will go for two-way analysis, sir, if in these four groups only?
Suppose you are having some another classification. So
Okay.
in two ways that you can classify the data. One is I'm applying for the let's suppose you are having the uh, first group persons are whatever the uh, on which one that you are applying these six observations actually how you are getting
In animals we are doing, sir, in
animal.
rats. In the
Okay, in
rats.
animals there are any groups are there?
In the animals, no, sir, but when we, in the animals also, sir, normally, instead of six animals, what we do in when we go for subgroups, we take nine animals. Nine
Okay,
animals we divide into three groups, like n is equal to 3, n is equal to 3, n is equal to 3. And each three, we collect the sample at different time points.
okay, the
You
time
got it?
points are also there.
Yes, sir.
So
So in
when you
the
are
first,
collecting about this one, then
huh,
you can time points is one aspect and the groups are another aspect. So then you can go for the two way.
okay, okay. Say for example, the same group set. One test group is there, blank group is there, and formulation, standard formulation is there, control is there. So in each group, what I am doing, we are keeping nine animals. Okay,
Okay,
and in these nine animals, from three animals we take it at 1 hour, other three animals 2 hour. Sample we take it second hour, and in the other three animals we collect it at the third hour.
okay,
Okay, so like this, the first test group, nine animals, we divide into three groups.
okay.
In the similar, in the case of the blank as well as the standard, as well as the, yes, sir, control group,
Control
control,
group.
control.
Hmm.
So, so here can we subject it to two-way analysis now?
Yeah, two way analysis.
So how I will subject the two-way analysis now, sir? Can you explain?
Now let's suppose if we are taking
Yeah.
uh, one, just I will share the one of the screen of the Excel.
Yes, sir.
Um, just like you are having A group,
Yeah. A group.
B group,
Yeah.
C group. Okay.
Okay.
And you are having the 10 minutes testing period,
Yeah.
uh, 20 minutes testing period,
Okay.
30 minutes testing period, let's suppose.
Okay, sir.
Now,
Yeah.
you are applying on one rat for the first one on uh, first group, or whatever the test group. you are
Okay.
applying the 10 minutes that you are observing, and you are writing the observation at here, some
Yes.
2.35 or something, whatever the reading that you are collecting it.
Okay.
And 10 minutes for the second group.
Yes.
So that observation that you are reading and writing at here.
Okay, sir.
Okay.
Yeah.
And third group and 10 minutes also that you are writing like at here.
Okay.
Similarly, the 20
But,
minutes for this one. So
yeah.
totally you are having the 9 the rads that you have taken for 3 groups and also 3 timings.
3 times, right?
Yeah. So I want to test whether the 10 minutes to 20 minutes to 30 minutes, was there be any difference in the readings or not?
Yes.
And simultaneously you are testing the A group to B group to C group. Was there be any differences there or not?
Yes, sir.
Then you can go for the two-way classification.
Okay.
That is our randomizer block design almost. Okay.
Okay, sir. Right.
So then when you are entering the data, you have to enter like this.
Yeah.
A, B, C. A is added 3 times. Okay.
Okay.
And there is no observation at here, let's suppose. Now
Mm.
B is 3 times.
Okay.
C is also 3 times.
3 times. Yes.
Okay.
Okay.
And just you delete this one. Correct.
Mm.
So just you are getting observations like this.
Yes, sir.
Then simply you can go for the univariate
Okay.
and whatever the treatment and replication that you send to the fixed effect and responses to the dependent list,
Okay.
and whatever the post hoc test if you want to A to B, A to C, those if you want to compare, and also 1 to 2, 10 minutes to 20 minutes, 10 minutes to 30 minutes, or 20 minutes to 30 minutes. If you want to compare, you select the post hoc test, either LSD or Duncan multiple,
Okay.
and just you click the OK button. Then you
Oh.
will get the output.
Okay, sir. Okay, sir. Right, sir.
Okay.
Yes, sir. Thank you, sir. Yeah.
So actually it is a menu driven, no need to write the program, only the option that you have to remember. That's enough.
Yes, sir. And one more thing, sir, with this particular tool of this one, what you are using,
Yeah, free tool.
SPSS, do we get even graphs also, sir, as we get in
Yeah.
the design expert?
Once Anusha, please show the graphs by sharing. Show how to draw the graphs generally. Yeah. Descriptive statistics, frequencies, crosstabs. Crosstabs means for every pair that you can go it, and no, ordinary graph that you show it. Yeah, bar graph. Okay. Just to explain, Anusha.
Sir, is it visible?
No, you again you share it, please. Yeah, now visible. This is percentage. So what are the values are there? 100. Okay.
What are the frequencies with respect to it?
Okay. The percentage bar diagrams, the values are same. So same heights it will showing it because equal are there. Unequal that you take and you can represent. So instead of that, some random data that you take and show it. Only univariate. You delete this data and show. Go to variable view and select this entire data and delete. Just select the entire data and delete. I will also show the later the design expert because I have to check it once the options.
Okay, sir.
Delete the total data.
Actually, I'm taking a new data set.
Okay, okay. Got? Processor is ready. You are taking the percentage bars. Instead of the bar that you take some other and you give the curves and all. Okay. Not frequencies. Don't take frequency. Frequencies means equal height that you will get. QQ plots. Yeah. Okay. The tables compare means and data diagrams are there?
No, sir.
Not there. Okay. Descriptives. The descriptives. So only X and Y. Yeah. Variable as to standard deviation and all this. Okay. But you are not entered the data. You are having any of the data?
No, sir.
Other data for drawing of the curves, bar diagram and frequency curves, frequency polygons.
No, sir. Actually, I don't
And
have.
okay. Okay, madam. I will show it in the later, madam. Okay.
Yes, sir.
Yeah. I will try today. I will download the version and I will update it. Okay.
Yes, sir. Yes, sir. Thank you, sir.
Okay. Now, shall I have to go for the factorial experiment?
Yes,
Or
sir.
shall I have to start tomorrow? Because
As you wish,
already,
sir. As you wish. I mean, I don't have any issues, sir.
uh,
Others also, I don't know whether.
sure.
Sir, you want to continue today or your choice?
Yeah, if I'm continuing, it will take more time also it will take. So what is actual time is up to 12 o'clock, no?
Yes, sir.
Okay. Okay, I will give the basic concepts of the factorial experiments. Now I will share the screen. Yeah. Now the factorial experiments. Is the screen is visible to all of you?
Yes, sir.
Yes, sir.
Yeah. Now, okay, factorial experiment. Scroll out on the screen.
It's అవ్వట్లేదు సార్ ఇంకా స్క్రోల్ అవ్వట్లేదు స్లైడ్ లోనే ఉంది టైటిల్ స్లైడ్ ఇప్పుడు స్లైడ్ అయింది సార్ ఇప్పుడు సెకండ్ స్లైడ్ కి మూవ్ అయింది
ఓకే స్లైడ్ షో పెడితే మూవ్ కావట్లేదు సమ్ ప్రాబ్లమ్ ఇస్ దేర్ now the factorial experiment in any experimental study the combination of more than one factor each at different possible combination of the levels under study then it is generally said to be a factorial experimental design. Let's suppose we are applying the nitrogen and phosphorus and some potassium. So if you are applying these individually, I'm assuming that the nitrogen is one treatment, phosphorus is another treatment, calcium is another treatment. Now, yeah, I'm applying these fertilizers to the land area individually on a particular crop and collecting the yields. So then generally you are going for the varietal trials, either completely randomized design or randomized block design or lattice square design. Suppose if I'm not applying these fertilizers as combined. So I'm applying, I'm combining of the nitrogen, that means these are mixed it. Nitrogen, phosphorus and potassium. So each is some 250 grams, 250 grams, 250 grams. Or one is at 500 grams, 500 grams and 500 grams. Or 250, 500, 250. Or 250, 500, 500. So that I'm taking the different possible combination. Like 250 I'm treating as a low level, 500 is high level. So that I'm mixing each nitrogen at two levels, 250 grams and 500 grams. Phosphorus 250 grams, 500 grams. And potassium also the 250 grams and 500 grams. Each is having with the two dosages. I'm mixing and forming the different treatments. So totally three are there and each is having two levels. Therefore, totally you are having the 8 possible combinations. So in that type of the cases, generally you are going for that means these factorial experiments. Now, in the factorial experiments, we are having major two types, symmetrical factorial and asymmetrical factorial. Symmetrical factorials are, I'm having the F factors, like 3 factors or 2 factors or 4 factors. And each factor has some levels and the number of levels are some Li. Maybe first factor is L1 levels, second factor L2 levels, like first fact nitrogen at 2 levels, potassium is at 3 levels, phosphorus at 3 levels, like that. Or it may be some equal number of levels. It may be variating it with the number of levels of the ith factor. If the number of levels in the factors are equal, then the corresponding factorial experiment will be L power F, that is called a symmetrical factorial experiment. So two factors, each is having two levels, that is called 2 square. And there are three factors, each has two levels, then it is generally said to be 2 cube factorial experiment. There are four factors, each factor is having only two levels, then it is the 2 to the power of 4. So L power F, that you remember, L stands for number of levels, F stands for the number of factors. Factors is always the power, not as a base, not F power L. Okay, most of them they are confusing, that's why I am giving L power F as a standard notation. So if there are two factors, each factor has two levels, then the factorial experiment is said to be a 2 square factorial experiment. Asymmetrical factorials means the number of levels of the each factor are differing it. So L1 may be equal or unequal to L2, and which are equal or unequal to L3, but all are equal, then you are saying that it is said to be a symmetrical factorial. Some are different, may not be all also. So such a factorial experiment is said to be a symmetrical factorial experiment. For example, let there are three factors are there. Let the first factor has two levels, and the second factor has three levels, and third factor has four levels. Then the asymmetrical factorial experiment will be containing totally 2 into 3 into 4, 24 treatments. So, and also that I'm going to use the various concepts or terminology in the factorial experiments. The terminology that what you are using are contrast, orthogonal contrast, simple effects, and total effect, main effect, and interaction effect. Actually, whatever the in the previous also that you can see treatment star block. So that is nothing but an interaction effect. Now, what are these? Contrast, orthogonal contrast, simple effect, total effect, main effect, and interaction effect. Contrast. Contrast means a linear combination of k treatment means, that is TIs, is the summation of CITI is called a contrast of the treatments. Let's suppose you are having T1 is the first treatment mean value, second treatment mean is T2, third treatment mean is T3. Okay, so treatment means that I'm taking T1, T2, T3, and I'm multiplying T1 with some constant value like 2 into T1 minus 3 into T2 plus 3 into T4. Okay, like that, whatever the summation of Ci value is must be equal to 0. Like 1 into T1 minus 2 into T2 plus T3 plus T3, 1 into T3. Then whatever the coefficient values, if you are adding it, 1 minus 2 plus 1, the value will be 0. Okay, so then it is generally said to be a contrast, not the sum of the treatment values. The coefficient values must be 0. Then it is said to be a contrast. Summation of Ci. Are you following or not? Like 1 T1 minus 2 T2 plus 1 T3. That value will be some value you are getting. That is said to be a contrast because 1 minus 2 plus 1 value will be 0. Next, the orthogonal contrast. Suppose there are two contrasts are there. One is the summation of AITI and other one is summation of BITI. Okay, and I am multiplying A1 with B1, A2 with B2, A3 with B3, and so on. And also, moreover, the summation of AI value will be 0 and summation of BI value is also 0. Okay, so if the summation of AI is 0 and BI is 0, and moreover A1 B1 plus A2 B2 plus A3 B3, that value is also 0, then these two treatments are said to be orthogonal to each other. One is orthogonal to the another. One contrast is orthogonal to the another one. Orthogonal is indicating that those two are independent. Now suppose if I taken the treatment and blocks that I had taken. So treatment, so you are having three treatment, let's suppose T1, T2, T3. Blocks are 4, B1, B2, B3, B4. Now I'm taking the some of the whatever the values are, these are also some 4 are there that are existing it. Then I'm taking the two treatment contrast and block contrast. So those two are independent if this value will be 0. So like that, whether they are independent or not, for that aspect, you are going to use this orthogonal contrast. Now, I'm explaining about the another one, simple effect. Simple effect is nothing but only directly you are considering the effect of the treatments or the blocks, and the total and main effect that I will explain with the part of the factorial experiment, because those are comes only in this part. Now I'm explaining the 2 square factorial experiment. Let there are two factors A and B. Each factor has 2 levels. So A is having 0th level and that is low level and high level, or presence and absence, like you can write. So 0 and 1. B factor is also having 2 levels, 0 and 1. Then I'm indicating the 0 level as A factor A0, A1, B0, B1. Now I am writing the different possible combinations. So A0, B0, A0, B1, A1, B0, A1, B1. So A0, B0 is entirely said to be a treatment at here. And A0, B1 is called one treatment. But whereas in the previous, A is one treatment, B is another treatment. So the difference that you can identify, what is the treatment in case of the factorial experiment? So combination of the factors with the different levels is treated as a treatment. So A1 B0 is another treatment. A1 B1 is another treatment. Okay. So nitrogen and phosphorus both are with 250 grams that is mixed it. That is one treatment. And nitrogen 250 grams and phosphorus 500 grams, which are mixed, that is another treatment. And nitrogen at 500 and phosphorus with 250 grams, that is a third treatment. And both are 500 grams which are mixed, that is the fourth treatment. So now these are applied. And whatever this is the factor model, because it is a mathematical model, you may not consider this one. And now the same thing that I'm expressing in the diagrammatical way. Here this is the factor, A factor on the horizontal x-axis, low level, high level. And factor B that I'm taking on the y-axis. Is it visible?
Yes, sir, it is visible, sir.
Low level 0 and high level 1. Now, whatever the combinations, 0th level and 0th level of A0, B0, that is called A0, B0. And A at high level and B at low level, this is the point. And similarly, A at low level and B at high level, this is the point A0, B1. And both are at high level, that is A1, B1. Now, so the same thing that what I explained. Now I want to find out the differences. What is the effect of A or what is the effect of B? So the effect of the factor A, what is the effect of? So how you are getting the effect of A? A effect that you can find out by keeping the another level fixed. So A1 B0 minus A1. So this difference is generally said to be an effect. So therefore A1 B0 minus A0 B0, that if you are calculating, that is called one effect of factor A at B0 level. And similarly at a high level also that you are calculating. Now sum of these two that you have to calculate, that is called total effect. Sum of this B, sum of those two is the total effect of factor A. Similarly, suppose we want to find out the factor effect of B. So how you are getting the factor B effect? So you keep A at low level and this point to this point, what is this difference? And similarly, this difference that you calculate. And sum of these two differences that you calculate, you will get the effect of the factor B. Now, what is the interaction effect? AB. So AB effect is both that you will apply at low level and both are at high level. So these two corners that you consider. And similarly, these two corners that you consider. So A1 B1 minus A0 B0 and A0 B1 minus A1 B0, if you are calculating, that will be the interaction effects. And sum of these two is nothing but the total effect, total interaction effects. Okay, that I will show in this one. The simple effect is individually that you are calculating, and total effect, the sum of the simple effects. Are following what is the difference between a simple effect and total effect? Simple effect is your one at a low level that I'm calculating. What is it? That is simple. And at high level again that I'm calculating, that is also called another simple effect. And total effect is sum of these two that I'm calculating. Similarly, factor B, sum of the two simple effects. Now, whether it is a contrast or not, here you compare the coefficient. Here, what is the coefficient of A1, B0? 1. Here minus 1. Here plus 1. Here minus 1. Therefore, it is a contrast. Now, even if you have taken this one, A1, B0 coefficient is 1. A0, B0 coefficient is minus 1. Therefore, 1 minus 1, the sum value will be 0. Therefore, it is also said to be a contrast. Therefore, simple effect is a contrast. This simple effect is also a contrast. And total effect, sum of these two, that is also a contrast. Okay. And similarly, factor B that I had taken. So this is also one simple effect, and this is another simple effect. This is also a contrast, and this is also a contrast. And sum of these two, that is called a total effect. This is also a contrast because sum of the coefficients is 0. Now I'm comparing uh, what is whether treatment factor A and factor B, whether they are orthogonal contrasts or not. That also I'm explaining it. Now you check it, the total main effect. So simple effect, this is simple effect. That is called total effect, and average means you have to divide with 2. And that is called the main effect of factor A. How we are calculating the main effect? the average of two simple effects of a factor is said to be the main effect. Okay, and similarly for the factor B, so two simple effects that you are adding and dividing with 2, you are getting the average effect that is called the main effect of the factor B. The same thing symbolically that you are writing. This is a symbolical notation. So generally, A1, B0, that is A is at higher level, B is at a lower level. Therefore, B is almost nullified. That's why I am indicating as A. A0, B0, both are at low level. This is a normal one. And A1, B1, both are at high dosages. That's why I'm writing A and B, both are significant. And A0, B1, B is at higher level and A is at a lower level. So that means B only that you have to consider. So that. So this is a notation that what you are going to use. The same thing generally in the notational aspect that you are writing, but generally it is very easy to remember this part. Okay. So these are constructed from the just like the table that what I had given. Are you following or not?
Yeah, I'm able to follow, sir. Understanding, sir.
Now, so this is the main effects calculation, and now the interaction effect. So interaction effect is between two factors is the average difference between the effect of A at higher level, high level of B, and the factor of A at lower level of B. So this is one interaction effect, this is another interaction effect, and both that you are adding it, that is total effect, and take the average of that. So average value is nothing but this is the interaction effect. Okay, so this is interaction effect, how we are calculating. Just ignore the last row. Now, each is already I told that which is also a contrast. Contrast is nothing but the sum of the coefficients is 0. That's why it is they are said to be a contrast. Now, whenever you are calculating the sum of squares of the main effects or interaction effects, so whatever the factor A, the whatever the value that you are calculating, this total value, the average effect that you are calculating, that you square it by R. R is indicating the number of repetition. And it is a 2 square factorial design, 2 square that you write. Okay, that's enough. And if it is no replications are there, then simply write 2 square by 4, that's enough. Contrast square by 4. And similarly for the sum of squares for the factor B. So contrast square by the number of replications into whatever the factor here k that I had taken as 2 only. Okay, so no need to ignore that part here. Simply you can write 2 because it is a 2 square factorial experiment. Okay, SA square that I am calculating. This you can write as 2. Okay. Right. Then once that you have calculated, you have to write this analysis of variance table. So analysis of variance table is containing main effect. So replication, sum of squares, and treatment sum of squares. This treatment sum of squares is splitted into ST square is splitted into 3 parts. But whereas in the ordinary analysis of variance, we are not splitting into the main effects and interaction effect. Whereas at here, we are splitting. Only treatment sum of squares is splitted into different parts. Okay. So that is the major part. So 1 degrees of freedom, sum of 3 ones is equal to 3. And whatever the sum of squares by its degrees of freedom, you are getting the mean square values and the variance ratios. So SR square by whatever the SE square, that value you have to calculate. And ST square by SC square. Similarly, even SA square by SC square. If you calculate, you can test the main effect of factor A. And SB square by SE square, you can get the effect of factor B. SAB square by SE square, you can get the interaction effect. Also, you can test it. So this is the analysis of variance for the 2-square factorial experiment. Okay, so this is what generally what you are doing, and this that we can I will explain with the example in the later case. Okay, so for today that I'm stopping. If you are having any of the doubts, that you can ask now. You're welcome for the doubts if you are having any. Any doubts?
No, sir. As such, I don't have any doubts, but I'll get back to you tomorrow, sir.
Okay, thank you, sir.
Thank you, sir.
Okay, thank you to all. So I'm closing the session today.
Thank you, sir. Thank you for your valuable class. It's very informative. Thank you so much.
Okay, thank you. Thank you. Thank you. Thank you, Anusha.
Participants, I'll be posting feedback link in the chat box as well as in the WhatsApp group as okay.